comes the rain again.
Good evening, I'm Martha Killen, and welcome to the Science Newscast. Tonight we have breaking news that could impact our community along with in-depth reports on the issues you care about. Stay with us as we bring you the latest updates about our weather, right in the comfort of your home. Or maybe you're on your phone while entering a suspicious white van. Either way, get ready for some news. First up, we have Sam Adams, who will be bringing us on a journey to explore the diverse and fascinating world of clouds.
Hello, I'm Sam, and I'm going to be talking about the different types of clouds. So, without further ado, let's hop into it. Okay, so the first type of cloud I'm going to be talking about is stratus clouds, which you can see around here. So, the first type, there are three different types of clouds: stratus clouds, stratocumulus clouds, and altostratus clouds. The first type I'm going to talk about is stratus clouds. Stratus clouds um, Stratus clouds are formed when a mass of air is lifted slowly upwards, and as warm air is being lifted, the water vapor condenses and forms a cloud that we can call stratus, that comes from the Latin word for layer. The second type is nimbostratus, which is right there. Nimbostratus clouds, not too much is really different about nimbostratus and stratus clouds other than two key differences. One, nimbostratus clouds actually fluctuate from a mid to low level range. And the second thing is that nimbostratus clouds, it's really in the name, nimbo. Nimbo is a Latin word for fog or rain. So nimbostratus actually, precipitates and makes rain or different types, but usually just rain. The third type is altostratus clouds. Altostratus clouds are similar to stratus and nimbostratus, which you could probably guess by the name. But the thing that is different is that it can range from 14 to 20,000 feet in the air. And although altostratus clouds predict arrival of warmer, wetter weather, they themselves do not produce any significant precipitation. For the next type of cloud, we're going to talk about cumulus. And this cumulus clouds actually have five different types: cumulus, stratocumulus, altocumulus, cirrocumulus, and cumulonimbus. Firstly, cumulus and stratocumulus. Not too much is different about these two clouds other than first, okay. Not too much is different about these clouds other than cumulus clouds are fluffy and clump like a marshmallow, while stratocumulus clouds are more laid flat. The next type of cloud is altocumulus. Altocumulus clouds actually range from a higher point, around 20,000 feet to 25,000 feet, and usually form in groups that are about 1 kilometer or 0.6 miles thick. The next type is cirrocumulus. Cirrocumulus clouds are also form in groups of about 1 kilometer thick, but the thing that separates them is that cirrocumulus hits a whopping 30 to 45,000 feet in the air. And finally, for the last one, is cumulonimbus clouds. Something that differentiates cumulonimbus clouds to pretty much every other cloud is that this cloud is the main cloud for storms. But have you ever heard somebody say, "Oh, it looks like a storm's coming, look at the clouds"? Well, this is the cloud that they're talking about right here. These clouds are just big, followed by massive amounts of rain, high winds, and sometimes hurricanes of some sorts. And they can actually reach such a tall height that they go into the troposphere and start flattening and have an anvil-like shape. And lastly, the final type of cloud is cirrus. There are three types of cirrus clouds: cirrus, cirrostratus, and cirrocumulus. We already talked about cirrocumulus. Cirrus clouds are formed when the ascent of dry air makes the small quantity of water vapor in the air undergo disposition into ice. Cirrus clouds are also a high forming cloud that can reach heights of 30,000 to 50,000 feet in the air. Similar to cirrus clouds, cirrostratus clouds also form very high in the air, but the key difference of these clouds is that the clouds take form of half stratus and half cirrus clouds, making it a highly flat laid cloud. And now I'll hand it off to Aubrey and Brenna for the amazing world of precipitation.
Hey, it's Brenna and Aubrey here, and today we're here to talk about precipitation. There are 6 different types of precipitation.
rain, snow, hail, sleet, drizzle, and freezing rain. But today we will only be talking about 4 of them: rain, snow, sleet, and hail. Hey, it's Brenna and Aubrey here, and today we're here to talk about precipitation. There are 6 different types of precipitation: rain, snow.
Hi, my name is Aubrey, and I'm going to be talking about rain and snow. Rain. Rain is formed when water from the Earth's surface evaporates up into the clouds. In the clouds, the water condenses and eventually becomes too heavy, and falls towards the Earth's surface. It passes through the Earth's troposphere. If the troposphere is above freezing, the droplets melt, turning into rain. And this is what rain looks like. Snow. Snow is formed Snow forms when the water vapor in the atmosphere cools and condenses into very tiny ice crystals. As these crystals come together, they create snowflakes, which grow larger as more water vapor goes into them. The snowflakes fall to the ground when they become heavy enough to overcome air resistance. The temperature and humidity conditions in the atmosphere determines the size, shape, and structure of the snowflakes, giving each one its unique shape.
Sleet. Sleet is formed when water condenses into ice and falls through a warm layer of air, then refreezes into small ice pellets as they fall through the colder layer near the Earth's surface. Hail. Hail is formed of frozen precipitation that occurs when updrafts and thunderstorms carry raindrops into extremely cold areas of the atmosphere. These drops freeze and grow in size as they are repeatedly tossed up and down within a storm. When hailstones become too heavy to stay aloft, they fall to the ground, sometimes causing significant damage to crops, vehicles, and roofs.
Oh my gosh, do you hear that? That's so funny because our next segment is about thunderstorms with Chase and Martha. Hi everyone, my name is Martha Killen. Today I will be discussing thunderstorms with my partner Chase Dorset. The question is, what exactly is a thunderstorm? Thunderstorms are powerful natural phenomena. They're characterized by thunder, lightning, heavy rainfall, severe winds, and sometimes even tornadoes. They typically form when warm, moist air rises and cools, which leads to the development of cumulonimbus clouds. Did you know that every day thousands of thunderstorms occur? That's crazy. There are 3 main stages of a singular thunderstorm cell. First, we have the cumulus stage. This is where water condenses on a surface which tends to heat the area it's connected to. The cumulus cloud gains water that concentrates around the cloud's condensation nuclei, which is the surface of the cloud. This process happens quickly because the warmer the surface of the cloud, the faster the updraft will be. The next stage is the mature stage. The water droplets are too heavy for the updraft of air to hold, and it begins to rain. This stage is the most destructive, bringing strong winds, rain, lightning, and sometimes hail. As the rain falls from the cloud, it creates winds that blow downwards called downdrafts. These winds can reach up to 170 miles per hour. That's enough to blow your grandma off her feet. Well, my time with you all has come to an end. I will now leave you with my partner, Chase Dorset.
Thanks for the intro, Martha. Now, where were we? Yes, the stages of a single cell thunderstorm. After the mature stage comes the dissipation stage. All winds are now downdrafts, and wind and rain get lighter and lighter until they eventually stop. Although these single cell storms don't usually last for over typically 30 minutes, if you get caught in one, your umbrella could be broken. Did you know that depending on atmospheric conditions or factors that affect the atmosphere, cumulonimbus clouds or thunderstorm clouds can give rise to different types of storms? There are 3 main ones to be aware of. First, we have single cell thunderstorms. These ones are short-lived, feature one updraft, and sometimes can produce heavy rain and sometimes lightning. Then there are multi-cell thunderstorms. These ones tend to be more powerful, cluster together, and last a bit longer. Finally, there are supercell thunderstorms. These ones are more powerful with a rotating updraft. They can occasionally produce large hail, damaging winds, and even tornadoes. While not all thunderstorms are dangerous, it is important to realize we must track them because of their rapidly changing conditions.
As we wrap up our discussion about thunderstorms, let's talk about one standout feature that superstorms can make: tornadoes. Anna Corell will give us a whirl of a performance.
Thank you, Chase. I'm Anna Curl, and like you said, I'm going to be talking about tornadoes. Tornadoes are one of Earth's most destructive phenomenons that is a big tunnel of wind that picks up any debris and crashes anything in its path. Basically, they arise from pre-existing thunderstorms that when hot air and cold air mix together to form a vortex of air that just spins and spins and spins and runs. Basically, so a tornado comes in stages. There is the first stage, which is the whirl stage. This is the updrafting of air forming the cloud that it comes from, basically the tornado or the thunderstorm. The vortex is when the air starts to mix and churn and go horizontally to make that spiral. Then there's the organizing stage, which is when it sets its base on the ground and it starts to run along the surface of the earth. After that is the mature stage. This is the most destructive stage of a tornado, where it just wrecks everything and it picks up all this debris, making it the dark color that you see right here. And then after that is the shrinking stage. This is when the forces of the vortex just get smaller and smaller and starts to disintegrate. And after that is the decaying stage, when it just fully dies. But sometimes it doesn't die. And that's when a water sprout comes into place. When a tornado is on land and it's been spinning and it's super duper strong and then just goes into water. And then this tornado is just on the water and it's picking up water. It's not really dangerous to us, but it's more dangerous to boats that are in the water. Oftentimes there's a small tornado called a dust devil. It's still a tornado, it's still a vortex, it's just not as powerful. They mostly happen around farm times in the spring and summer, but still pretty dangerous. You don't really want to get caught up into one. Hurricanes. Tornadoes are categorized into a category called the Fujita scale. Basically, it's a rating that counts down from F0 to F5. F0 being the weakest, F5 being the most powerful. One of the worst tornadoes that we've ever had was the tri-state tornado in 1925. Basically, it was a F5 tornado that hit in Missouri and Illinois and wrecked everything. There was thousands and thousands of deaths and millions worth of dollars of home damage. But yeah, tornadoes are one of Earth's worst enemies, but also most common. One of the most common. So yeah, that's all I have today. Next up is Mason with hurricanes.
Thanks, Anna. Now, anyways, this is Mason G. Feller signing on, and I will be talking about hurricanes. Hurricanes are significantly more destructive than tornadoes. Hurricanes can have a diameter of a few hundred miles. This all starts near the north and south equator. Hurricanes start out as a tropical disturbance. This depends on the warmth of the water and moisture of the air. Wind blows along the low pressure pocket, causing rotation. If the wind reaches a speed of 23 miles per hour, it's categorized as a tropical depression. A wind of 39 miles per hour it's categorized as a tropical storm. Once wind speeds are 74 miles per hour, it is now a hurricane. Hurricanes can be categorized into danger levels of 1 through 5, with 5 being the strongest with winds over 155 miles an hour. The center of a hurricane is called the eye. This is the calmest part of the storm. The eye wall, on the other hand, is a cylinder of whirling clouds and rain that can be several miles high. As the clouds and rain rise up, it exits at the top and is thrown into a spiral. As hurricanes move towards land, it weakens and turns into several thunderstorms. The winds then produce huge waves called a storm surge. This, in turn, causes immense destruction along coastal lines. The largest storm surge in 1899 was 43 feet high. Anyways, this is Mason signing off with storms. Anyways, on to you, Ben.
Thank you, Mason, for that wonderful example on hurricanes. And now I'm here with our weekly weather. So Tuesday, today, we will have, you can expect some rains, about 50%, 54% rain, chance of rain, sorry. And it'll be a high of 55 and a low of around 40-ish. And Wednesday, we'll continue with that rain with a 71% chance of rain with a high of 55 degrees and a low of 40 degrees. Thursday, we will keep that rain train rolling, and that one will be a little bit cooler. That's the one where we drop here with a high of 44 degrees and a low of 26 degrees. Friday, the weather drops one more time with a high of 41 degrees and a low of 24 degrees. That day we'll get a little bit of a break from the rain though, so thank goodness for that. Saturday though, we'll get right back into some rain with a 59% chance and a high of 46 degrees and low of 29 degrees. And then finally, Friday, the 22nd, we can expect a little bit of snow mixed in today with a high of 45 degrees and a low of 23 degrees. Some light snow, 50% chance. And now here is Chase to finish us off for this broadcast.
Thank you for joining us this evening, or whatever time it is you're watching. That's all for tonight, and we appreciate your time, and we encourage you to watch other newscasts and stay informed. We will never have any news again. Good night.
Drenched in my pain again, becoming who we are.
Oh my goodness. Oh my goodness. Oh my goodness. Sorry, I lost my place.
Path, destructing everything. I'm okay.
When September ends,
Condenses and it just takes up everything in its path. And